So if we read this question line by line, it is saying that you are given two non-empty linked lists representing two non-negative integers, and the digits are stored in reverse order. So we have these two linked lists that you can see in the diagram as well, and both of these linked lists are representing some number. Each of their nodes contain a single digit, and add the two numbers and return the sum as linked list. So we need to add these two linked lists, the number which they represent, and return the sum as again as a linked list. So here you can see, right? And the catch is that this number is not exactly 243. It is 342 because the number is stored in reverse manner. So whatever is seeing first is actually a last digit, followed by till your last first digit. You may assume that two numbers do not contain any leading zero except the number 0 itself. So while summing, they are saying that they don't contain any leading zero. So after 243, after first digit, you won't have the numbers like this. You won't have the number like this 0 0 1 2 3 or 0 0 5 4 3. So there will be no leading zero in any of the number that question is saying that you don't have to worry about the leading zeros in any of the test case. And if we look at now, one quick brute force approach that comes into my mind is I can given this first linked list, I can convert into an exact number. I can store into an integer data type. Again, the second linked list, I can convert into its exact number, store it into an integer data type, and then sum them. I get a new number, and using that new number, I can create again a resulting linked list. But there is a catch. If you look at the constraints, you can see that because each node can have a single digit only, so it's ranging from 0 to 9. But the maximum number of nodes that you can have in any single linked list is 100. So it's going from 1 to 100. So you can so the maximum number will be 999 till 100th digit. So it will be a huge number. You won't be able to store it into a integer of type integer or type long int, right? Because let's see what is the range of integer data type in C++. See, so this is the maximum number that you can store into an integer data type, that is a 32-bit integer, and that's 1 2 3 4 5 6 7 8 9 10. So at most 10 digit you can store, but our problem can have a maximum number of 100 digits. Even in a 64-bit system, it still won't have the 100-digit number, right? Even if you take the unsigned integer, if you take only positive numbers, that will also not be enough to store your maximum possible number that we have in this current problem. But definitely we can't convert this linked list into an actual number and then compute the sum. So we need to solve this problem smartly without actually extracting the exact numbers behind each linked list. So now whenever we add numbers, how do you do it? So let's take the same example that we have in this problem. So we have this 2 4 3 and we have 5 6 4, right? So whenever we add, so actually this number is not 2 4 3 since it's stored in reverse order, so it is 3 4 2 and the second number is 4 6 5. Why is it? Because the question itself is saying that this linked list stored the digit in reverse order. So if it's in reverse order, we start, this is the first number, this is the second number, this is the third number, right? Third digit. So this is how these two actual numbers we have. And whenever we add two numbers, we'll always start from the last digit, right? We add these two, then we add these two and take the carry forward, then we add these two numbers, right? So in the basic mathematics, we add numbers from the last digit, and also in this linked list, the first digits are what we needed to add first. So this is kind of favoring us. So what we have to do, just start traversing in your linked list. And so if I So if I show you that we need to first add these two numbers, so make an empty linked list. So you can make an empty node here. So forget, assume that you don't have this resulting linked list yet. So you to add these two numbers. So whatever value you get while iterating into these two linked lists, so you need to do a simultaneous traversal into both linked lists. So whatever you get, add it to here, and you need to also make one variable to keep to store your carries. Now whenever you add two digit number, you always get a, you at maximum you can get a two digit number, because if you add 9 plus 9, you will get 18, right? And this is the maximum number that you can get whenever you add two digits, because to get the maximum number, you need, I have taken the maximum number or maximum digit in a plus b, right? This is the maximum number that you can get. So this will always be the carry will always be a single digit. So if this is 6 plus 4 is 10, then the number that we keep here is 0, and the carry will be 1. So carry will always be 1 or 0. In the case there is no the resulting sum is not of two digit, it's of single digit. For example, 3 plus 4, then in that case carry is 0, right? So whenever you do add two numbers, you just look up what is the carry. So if I add 4, 6, 7, and since I see that the carry is 1, so I also add that here. So just like that, we need to keep traversing the linked list, keep adding numbers, and whatever carry you have, keep store it in a separate variable. At each step you need to add the carry, right? So how will it look in the code? So what we can do, because we need to return a resulting linked list, so I'm making a node which I'm calling head, and let's say it's a new list node, right? I'm making a new node. Now definitely I need to traverse into both of the L1 and L2. So what I'll do, till L1 is not equal to null and till L2 is not equal to null, I keep traversing into both of them simultaneously, right? And now the one thing is that initially what number you will keep in the head, that will be your sum of the first two digit, right? So I can do one thing, let's just keep head as null, and I need one variable to iterate into the linked list, so I can create one iterator as well. Initially it will also be null, because if my head is null, right? So what I'll do, and also let's because see, both of these two linked lists cannot be of equal length always, like, right? So for example, you can have one linked list which is of 3 digits, which is 4, 6, 5, and there is another linked list which is of 2 digit only, 3 and 0, right? In that case, actually this will be you will add these two numbers, then these two numbers. So while making the I mean when you exhaust one of the linked list, which is a smaller linked list, you just need to simply store the rest of the number in your linked list, and you definitely you will add carry also. So what I'll do, I don't keep this AND operator, I just do that either of them is not null, I'll iterate into them, and I can handle both of them being null inside of a while loop, either of them being null inside a while loop. So what I'll do, I need one sum, and that sum will be whatever value I have in L1, right? Now this L1 can be null because this OR condition is saying that if L1 is null but L2 is not null, then still you will enter into the while loop. So what I'll do, first of all, we need a one variable to store the carry, right? To keep track of what carry is. Initially carry is 0. So what I'll do, I add, because carry is also a part of sum, so I keep a carry in the sum. Then if this L1 is not equal to null, I'll add L1, whatever value I have in L1, to the sum, right? L1 arrow value, right? Similarly, if L2 is not equal to not null, if L2 is not null, what I'll do, I'll add L2 also in that sum. Sum plus equal to L2 arrow right? Now eventually this sum will go into some new node, and we see that if in the first iteration we don't have any new node, so I can make one if condition that if our head is equal to null, that we don't have any node yet in our resulting list, then I'll do something. But if head is not null, we already have some nodes in our resulting linked list, then I'll do something else. And what will I do? If head is equal to null, then in that case there's no node yet in our resulting linked list, so I assign a new list node to our resulting linked list. And what will it be? Is it sum? No, it won't be sum, it will be actually sum modulo 10, because whenever you add 2 digit, that could result into a double digit number, right? For example, 9 plus 9 is 18. In that case, we are only interested into the last digit. So whenever you add, so let's say you have 9 then 9, so whenever you add, you keep the 18 here, and whatever number you have, you carry forward it for the next sum of digits, right? So if the 9 plus 9 is 18, if I want this its last digit, I just do its modulo with 10, because when I divide 18 with 10, as a reminder, I'll get 8, right? So to get the last digit of any number, it's a general rule that to get the last digit of any number, just take its modulo with 10 and you will get the last digit of that number. It's applicable to every number. Even if you have 3, 4, 5, if you do its modulo with 10, if you divide it with 10, the remainder that you'll get is 5. So to get to know that what is the last digit of this number, that will always be and that you can always get by doing its modulo with 10. So this is what I'm doing here. Now I have created head. Now I will assign iterator with also head, so that, because see, when I iterate forward into my linked list, I may lose the track of my head. So that's why I'm keeping separate variable of head, and ultimately I should after this while loop is exhausted, I'll return head, right? Because iterator will always be pointing to the last node when it would keep iterating on my single linked list, right? So this is what I did, but this only happens in the first iteration. In a subsequent iteration, the head won't be null, and iterator also won't be null. So what I do, I just append to the existing node. So iterator next. So in that same node, which is iterator, I'll add a new list node. I add a new node, and again the last digit of that sum, right? And how do we store the carry? Simply just store in this carry variable. So what will be the value of carry now? Now since it always be a second 2-digit number, and we need the first digit of that 2-digit number, you can simply divide it by 10, because whenever you divide any 2-digit number, so for example you have 29. So if you divide by 10, it will be definitely 2.9, but since you are storing it into an integer data type, so 2.9 will be automatically be converted into a 2, right? It will C++ will truncate this 0.9, so it will try to convert this floating point number into an integer data type, so it will be converted into its nearest number, that is 2. That is true for any two-digit number. If you divide it by 10, you'll always get the first digit, and since the carry is stored in the first part of this number, so we'll capture the new carry by dividing the sum by 10. So this is how I'll store the carry. So we are in each iteration we are adding the carry, right? First I kept the carry, I added the first number if that is available, I added the second number if that is available. I should not say number, the first digit and the second digit. So if I have available the first digit, if it's not exhausted, I'll add it. If I have the second digit, if it's not exhausted, I'll add it, right? And these two things are this if else block is handling the first case when we don't have any node, and the second case when we have some node in our resulting linked list. So head is new list node, then we iterator to iterate into that, and iterator in the next. So in the next iteration it should refer to the last node always. So what I'll do, I'll assign the next node of this iterator into the iterator variable, right? I hope you are understanding this, because in the next iteration I am not interested in this current node, I am interested in the next new node that I have added. So the new node that I added into the tail of this particular iterator node, I will assign this, I will update its reference with the next node, so that in the next iteration I'll deal with this particular iterator only, right? So let's see if that works, because this will do the sum, and ultimately will return the head. There is some compilation error that L1, okay, I should say L1 is not equal to null, right? And let's just store them into parentheses. Now let's see. Okay, so it's saying memory limit exceeded, so probably we are iterating forever into. Okay, so what I missed is that when I referred the value of L1, when I referred the value of L2, we need to move forward in both of the linked list, right? So that I missed here. So L1 should be updated with L1 arrow next. Similarly, your L2 should be updated with L2, because to iterate for the next node, we should get rid of the current reference. Now let's see. It's saying wrong answer for this particular case. Now definitely it will be a wrong answer for this particular case, because what we missed is the one edge case, that even if we exhausted both of the linked list and we added them, we might after the last iteration we still be left with some carry stored in our carry variable, right? And this happens when you add such kind of number 99999. So when you added this 99, you got one carry. When you added this 99, you got one carry. So at each step you're getting one carry, and one will forward here. So let me show you in the notebook. So it will be like this. So if you have 9 and numbers are like this, so this is the first linked list and this is the second linked list. So when you add so you can assume that this is the last digit of my number and this is the last digit of a number, because I'm adding that way. So 9 plus 9 is 18, carry forward here. 9 plus 9 is 18, carry forward here. And now 9 plus 1 is 10 and carry forward here. 9 plus 1 is 10. Now in the last iteration, when you add 9 plus 1, you always left with a carry, and by that point after this iteration you are exhausted with your both of linked list. So you have some carry available still in your carry variable that you need to put it somewhere, right? You need to append into your list. So one edge case we need to keep it here as here is that if carry is still there, what you do at your iterator, um, put a new node which will be equal to your carry. Yeah, this will take care of the um, residual carry even if we exhausted all of the numbers of both linked list. Yeah, so this works. Let's try to submit it. Yeah, so this was it. I tried to explain it the very best. Even if you still feel that you were not able to follow me correctly, you guys can comment down and I can ask you further. You can ask me to uh, explain you guys this in further detail.